This is Algebra lesson 9.6, exponential functions. What that means is it's very simple. It's when the exponent itself is a variable. Y equals 4 to the x. Have you ever heard somebody say, like exponential growth, or people want their business to grow exponentially? I will explain. Something that has exponential growth. Let's do this really quick. I will do this one for you, just so you can understand how crazy exponential growth is. Okay, and how insane this becomes. This right here gets out of hand very quickly. And you're like, what are you talking about? It gets out of hand. Let me show you. Let me draw you the graph. Actually, here, let me draw you the graph. I'll do it down here just so we can actually have a little bit of room. Okay, here we go. We're going to start this. How do we always start this so you can visually see it? What do we start with? If I want to graph this, what am I going to do? Just to show you how to do it, what am I going to do? How do we always start this? Anytime we're going to start the graph, the first step on anything, we always do something. How do we do it? What's the process? When I first showed you how to draw a linear equation, when I first showed you how to do that, what did we do to start beginning to graph it? What did we do? What was the process? No, what? What was that? Make a table. You make a table so we can just graph it, right? So you can see how it works, right? We make a table. Let's make a table here. Y equals 4 to the x. Okay, let's make a table over here. Let me erase this. I'll move it in case we run out of room. Y equals 4 to the x. Okay, so then we'll make a table. What should we choose x to be? Let's go, let's start with -2, -1, 0, 1, and 2. Let's do the originals. Do you agree? What? You can't have a negative exponent? What is 5 to the -2? What does that mean? You don't remember this? What is a negative exponent? Should we go back? Okay, I'll pause this. Now that we had to take that little quiz, does this make sense now? That it's going to end up being 4 to the -2, which is... So then, what is that going to end up being? If when x is -2... What is the answer then? What is y equal to if x is -2? 1/16, right? It would be 1 over 4 squared. What is 4 squared? 16. So it's 1 over 16. So it's 1/16. Well, what if x was -1? What is y then? Y equals 1/4, right? It's just 1/4. Right? You remember this? Okay. What about when x is 0? What's y equal to? Wrong! Oh, that should have been 1 right there. I should have put that on the quiz. Anything to the 0 power is? 1. Oh, man. Oh, my goodness gracious. Anything to the 0 power, people? What if x was 1? Y equals 4. And when x is 2, then y is 16. Can we graph this now? -2 and 1/16. That would be... I got to make this much smaller. Okay, -2 and a 16th. That's way too far away from the line, but that's as close as I can get it. You see what I'm talking about? -1 is 1/4, which would be something like right there. Yes. 0, when x is 0, y is what? 1. It's right here. When x is 1, y is 4. And when x is 2, y is 16, 4, 8, 16. What if, so look at this, do you see that? What if I was to make x be 3? What would happen here? You need to see it. What if I was to make x be 3? Where would it be? How high?
16 times 16.
It wouldn't be 16 times 16. It's 4 to the third. So 4 times 4 is 16. 16 times 4. So it would be at 64. So I would shift this thing over one space this way, and it goes up 64. The next time it gets 4 times bigger, it would be 256. Shifting over 1, we'll move it up to 256. The next time over just 1, now we're up to 1,000. Do you see what I'm talking about when I say it quickly gets out of control? Do you see what I'm talking about here? I mean, like I move it over 1, now boom, it goes up even higher. Move it over 1, and oh my goodness, move it over, oh my, it would almost even, so anyway, we'll graph this now. What if I did this? What if I made x be negative 3? What would happen? No, well, listen, when x was negative 2, what happened? When x was negative 2, notice what's going on here. We're going to graph this. We're going to graph it. Oops. We're going to graph it. Right? What's going to happen here? No, listen, look. I'm not going to tell you what to do. What if x was negative 3? You tell me what the answer is right now. Write it down. What if x was negative 3? What's the answer? I'm not going to baby food feed you anymore. What What's the answer when x is negative 3? Y is 1/64. What's going on there? What is 1/64 compared to 1/16? What is 1/64 compared to 1/16? It's a lot smaller, right? Agreed? Would you like a 64th of $1,000,000 or a 16th of $1,000,000? Oh, you understand the concept of fractions. Believe me, I know you do. Right? What about negative 4? What's going to happen? It will be 1 over 256, which would mean that if I made x 4, it would be 256. Now, so notice this though. So if I made x 3, if x is negative 3, now we're talking about it's 1/64. Can I draw that? Is there any way for me to possibly draw that closer? And then if I make it negative 4, it's even closer. So tell me what's happening here. What's going on here with this? What do you see is going to happen? It is going down. Do I need to keep going for you to see the pattern here? Okay, so hold on. Let's keep going. What if x was negative 5? What's going to happen? How much? What do you mean smaller? It gets what? It gets closer to the x-axis, right? It's going to be 1 over some bigger number. And then the next time if I move it over even more, it's going to be 1 over an even bigger number, right? And then it's always going to be 1 over something, which means it's going to be greater than 0. It's going to be 1 over a number, which is going to be greater than 0. Will it ever actually get to 0? No. Never's going to get there. So this part of it right here, that guy is going to continue to get closer and closer to the x-axis, never touching it, right? And what's going on with this guy over here? What's happening over here is that it continues to get steeper and steeper, and it's going to get so steep that it will eventually look like to the naked eye that it's a vertical line, right? But is it a vertical line? No. So then, let's talk about the domain here. What's the domain of this thing? Is this thing going forever that direction? Yes. Is it going forever that direction? It is. No matter what I choose, even if I chose over here, how high would this thing be when x is there? It would be, but will that line eventually get there? Yes. This arrow here is going to the right. It's just going up way more, but it is still going to the right. So the domain is all real numbers, right? What's the range then? Is it going up forever? Yeah. It is going up forever. Is there a bottom? Yeah. Not really. There really isn't a bottom, but one thing we do know is that what is it never going to hit? Zero. So then what would you say is the range? Everything greater than zero, right? It's never going to hit zero. It's not going to be or equal to zero. It's all numbers greater than zero. Make sense? Okay. Something else I want you to be reminded of is, where did this thing cross the y? 1. Okay, so notice this. What you want to do, anytime you have an exponential function like this, you need to find where it crosses the y. How are you going to find out where it crosses the y? How are you going to find out? How do you always find out where it crosses the y? When x is 0, right? Because listen, I need you to understand this concept again. I'll remind you, this y-axis, the y-axis is x equals 0. Show me, if I was to have you graph for me x equals 5, how would you graph that? How would you graph x equals 5? Show me with your arm. How would you graph x equals 5? You'd have a vertical line like this, and where would it be at? At 5 on the x. So tell me, where is x equals 0 then? It's right there. It is the y-axis. Do you understand what I'm saying? The y-axis is x equals 0. So if you want to know where something crosses the y, what do? You make x be 0. Wherever it crosses the y, when x is 0, is the y-intercept. Do you all understand what I'm saying here? Give me another name for the x-axis. It is a line. What else can you tell me? Y equals 0. The x-axis is y equals 0. Right? You want to know where it crosses the x? Make y be 0. What? X doesn't equal 4. Right. When x was 0, what was y? Right. That's the y-intercept. Isn't it? Isn't it? Right? When x was 0, y was 1, which makes the y-intercept 1. Make sense? What I want you to do, your assignment today is going to be to make a table all day. Is to make a table and graph these babies. That's it. Make a table and graph them. There is a few another concept that you need to have. I do think I do this, don't I? Yeah, right. Okay. Another concept that you need to have is this. When you make a table, you've seen things like this. Yeah, X and Y. And it goes 1 is 3, 2 is 6, 3 is 9, 4, 12, 5, 15. We'll be done with that right there for now. What is true about this? Let's look. Tell me what. If I was to graph this, what would it look like? This is a line. How do you know what's going on? It's consistent. From here to here is plus 1. From here to here, plus 1. Here to here, plus 1. Here to here, plus 1. right? Here to here, plus 3, here to here, plus 3, here to here, plus 3. So what would the slope of our line be? Do you remember? What's the slope formula? Rise over run. So there's another way of writing that. What's the slope formula? The change in... It's the change in y over the change in x, right? So then what would the slope of this line be? The change in what? Y over the change in x. What's the change in y? What's the change in x? It's not 1/3. What's the slope? 3, right? This is consistent, and that's why, right? It's now, what about this? Why is x always like this? Why is x always like sequential and easy? And well, how come? Because that's the numbers that you choose. You always remember, you're putting money into the machine. You're putting stuff into the machine. The function box. You remember what I'm talking about? The function box? You're putting the coin in. Now you're looking at what comes out. Well, you get to choose what goes in. The machine decides what comes out. Does that make sense? That's why x's are always the one that's like 1, 2, 3, 4, 5, or -2, -1, 0, 1, and 2. Why are they always like that? Because we get to pick. What about this though? What if I have this? Okay. It looks like it would be consistent. And it is consistent in a sense, but watch, here's the deal. What's going on here with the x's each time? +1, +1, +1, +1. What's going on here? This is +2. Oh, this is +4. Oh, this is +8. Oh, this is +16. Is this a line? No, this is not a line at all. Okay? This right here, what's that going to look like? Let's graph it really quick and you tell me what this thing looks like. My line's awful. We're going to... The first one is, you agree that's 0.12? 1, 2. The next one is 2, 4. The next one is 3, 8. The next one is 4 and 16, way up here somewhere. What does this look like it is? What is it? We don't have the bottom. But what is it looking like? At this point, it could be one of two things. At this point, it could be one of two things. What is the possibilities here? It could be a parabola, right? This could be the right side of a parabola. Do you agree with what I'm saying? It could be. What else could it be? Could be an exponential function, right? It could end up going like this and bouncing and becoming a parabola, or it could be like this and go over here like this. We don't know based on the information here, but what we certainly know is that this guy right here, what is he for sure not? He's not a linear, right? He's not linear. He's not a line. He's definitely got a curve to it. Does that make sense? Now, here's the deal. Here's the deal. I am not going to show you right this second how to do this. We do talk about this. I believe it's next chapter. I mean, not chapter. Next, is it this? Oh, no. Yeah, it's the next time we have a lesson we get into this. Because there is a way to look at this, to look at our table, and see and notice that, oh man, what is that? And it will tell you whether it's a parabola, an exponential function, or a line. Just by looking at it and seeing these numbers here, +2, +4, +8, +16, etc. Does that make sense? Okay. I'm going to have you, well, anyway, let me give you your homework. This is not going to be super difficult. You like those one-question quizzes? I like them. I love them. When you guys forget stuff like, how to add. Yeah, no, I love it. It's my favorite. Is today Monday?
Friday.
You wish. Page 570. I say I have 1 through 19 even. That's probably too much. Let me look.
1 through 2 even. Oh yeah. 1 through 2.
Okay, I changed my mind. Here's the deal. Don't be too excited. I'm going to give you some questions. I want this. Here's number 1. Making a table and graphing them. I want to see the table and the graph for your homework. You're going to start right now. This is going to be your homework. I mean, I'm just giving it to you. You're just writing this down on your homework page. This is not a quiz. I'm creating your homework for you. Okay, and here's the deal. Every time you make your table, what numbers do I want? Thank you. You know it. I want -2, -1, 0, 1, and 2. Those are the numbers that I want in your tables. You're graphing those 5 numbers each time. So that's what I'm looking for here. I also want you to tell me the domain and the range for each. Does that make sense? Okay. I am going to change one thing here really quick. I'm going to make number 2 be this. Say again. I want the domain. So here's what you're doing. Are you all paying attention? This is exactly what you're doing. You're going to make a table with those 5 numbers, -2, -1, 0, 1, and 2. Then you're going to graph it using your table. Then you're going to give me the domain and the range, right? And I would like for you to then also tell me what is the y-intercept. So write all that stuff down for each one. So there will be a total of 1, 2, 3, 5 questions for each one. No. We'll say domain is different from the range. So domain, range, y-intercept, table, and graph. That's the 5 questions for each one. Table, graph, domain, range, y-intercept. You all understand what's going on? 5 questions per, so 15 total points.